Dear students, today we are going to talk about organic chemistry. Under organic chemistry, we will be talking about what is organic chemistry, what are organic compounds, what are hydrocarbons, types of hydrocarbons, homologous series, and its application. Let's start with it. Organic chemistry is the study of hydrocarbons and their derivatives. Now, what are derivatives and what are hydrocarbons? Hydrocarbons are compounds containing carbon and hydrogen only. Hope you understand. Derivatives are the compounds which are prepared by the reaction of these hydrocarbons with other elements or substances. For example, fluoromethane is a derivative of methane. Now, what are different types of hydrocarbons? The main types of hydrocarbons are saturated and unsaturated hydrocarbons. What is the difference between saturated and unsaturated hydrocarbons? A saturated hydrocarbon mean there must be at least one carbon to carbon single covalent bond. In short, we can say that in alkanes, which are, saturated hydrocarbons, alkanes. What are alkanes? This is a homologous series. We will study up this. Next slide. It is homologous series. So, just like we have counting at the same time, alkanes have it's their own series. We will discuss the series of alkanes next slides, inshallah. Um, all alkanes are saturated because they have, for example, this is pentane. The pentane has five carbons. These are hydrogens at the top of these bonds. These are covalent bonds. You see, all carbons have single covalent bond with each other. If even there is one double covalent bond or triple covalent bond, this will not be called as saturated. Okay, what is unsaturated hydrocarbon mean? Unsaturated hydrocarbon mean they must have at least one carbon to carbon double covalent bond, just like alkanes. All other atoms, other bonds can be single, but they must have at least one double covalent bond. This is a double covalent. Now, what will be the effect on uh, properties of, like, say, this is a member of alkanes, this is a member of alkenes. Alkenes are all unsaturated. Alkanes are all saturated. Alkanes have general formula of CnH2n plus 2. If carbon number is 2, hydrogen number will be double of carbon number, and we will add 2 to that answer. If it is C2, it will be 6. Now, 2 into 2 is 4 plus 2 6. C2 is 6. This is ethane, a member of alkane series. Okay. Then in this case, this is butene. Basically, butene is alkenes with four carbon. It has at least one double covalent. You can see this is the double covalent bond between these two carbons. Now, due to the presence of double covalent bond, the nature of the reactions will change. It will undergo addition, while alkanes undergo substitution reaction because all single bonds, all carbon electrons, four electron in outer shell, they are involved in bonding by, in case of unsaturated hydrocarbons, uh, we can see due to the presence of a double covalent bond, two hydrogen atoms are reduced. That is why when we will break any double covalent bond, electrons will be available for adding new atoms in it. In case of alkanes, we have to replace one atom with another first, because they undergo substitution reaction. Saturated hydrocarbons are the hydrocarbons containing at least all single covalent bond between carbon, while unsaturated hydrocarbons must have at least one double covalent bond. Yes, if they have more than one double covalent bond, they will be known as wholly unsaturated. Wholly unsaturated. For example, you can see here is double bond, here is double bond. Carbon valency should not be more than 4. This is unsaturated, but it has more than one double covalent bond. That is why it is called as wholly unsaturated. Hope you understand. If you have any question up till now, please write in comment box. I will be helping you to solve your problem and enhance your understanding. Okay, now let's talk about homologous series. Basically, before this, I want to tell you some a table containing homologous series of alkanes. You can see this table. This is homologous series of alkanes. Must keep in mind, alkanes have alkanes, these are alkanes, and this is homologous series of alkanes. These are the first members, first five members of alkane which are given to you, and uh, you need to know the names of first five members and their chemical formulas. For example, the first member of homologous series of alkanes is methane. So, as methane is the first member, it must have one. Its molecular formula will be CH4. Why it is CH4? You might have studied in covalent bonding. Each carbon has 4 electrons in outer shell. It will be making 4 covalent bonds with 4 carbonate hydrogen. That is why it is. That is why it is known as alkane, and it has one carbon atoms, 4 hydrogen atoms, because it is saturated. And you can see the structure of methane, that is CH4. As carbon has 4 electrons in outer shell, that is why it needs 4 electron. It will share 4 electron with 4 hydrogen atoms. Similarly, second member is ethane. Third member is propane, butane, pentane. After this, we have hexane, then heptane, then octane, nonane, decane. This is pentane, this is first member, this is second member, this is third member, this is fourth member, members, this is sixth, this is seventh member, eighth member, ninth member. So now, if you know this general formula which I'm writing here, which is general formula of alkanes is CnH2n plus 2. You know, this is a homologous series of alkanes. All the members will be following this formula. If we know the number of carbon atoms, then we can tell how many hydrogen atoms we have. Now, because let's say if carbon number is 2, just double the 2, that is 4, just 4 will be 6. Similarly, you can see propane has 3 carbons. Hydrogen will be double of 3 plus 2 will be 8. Similarly, butane has 4 carbons. Hydrogen will be 4 into plus 2. 4 is the carbon number and 2 is the is multiplied. We have to double it. 2n plus 2, it will be 10. This is how members of the homologous series, their general formula can be made if we know the general formula contains. So after pentane, we have hexane, which has 6 carbons. You can complete it now. Number of hydrogen atoms. This for you. 6, then double the number of carbon atom, which is 6. 12. Just add 2 into it. You will be having 14. This is molecular formula of hexane. Similarly, heptane has 7 carbons. Then add hydrogen, it has 8 carbons. It is 10 carbons. 10 carbons. So the hydrogen number will be double plus 2 of alkane number. Hope you understand. Due to this homologous series, we can easily predict the properties of every member. Let's discuss this one in the characteristics of homologous series. You must keep in mind the definition of homologous series can be asked in the past. And it carries 2 marks. Okay. This is homologous series. Uh, First, you need to know definition of homologous. This is applicable to all organic compounds. Here we are talking about a homologous series of alkanes and alkenes. What is that? Define it is a series of organic compounds in which consecutive members is very important. Consecutive members they differ by 1 carbon and 2 hydrogen atoms only. These words are very important. Between 2 members, let's go methane, ethane, as I told you earlier, you see there is difference of 1 carbon and 2. C4H8, this is methane, ethane, propane, butane, and then we have pentane, and so on. We already showed in the previous slide. Now, what are the characteristics of homologous series of any organic compound? For example, alkanes, kenes. So let's talk about the properties, characteristics by which we can identify which group it belongs. We have same general formula. As I told you, alkanes have CnH2n plus 2. Alkenes have CnH2n. So the carbon number as 4, which will be double of carbon, that is 8. So, alkenes, I told you, they are unsaturated. Hydrocarbons, they must have double covalent bond. It can be prepared by similar methods. Their type of reactions will be, same or similar. All the alkanes can be prepared by substitution reactions, while all alkenes can be prepared by addition reactions. As alkenes are unsaturated, their physical properties change gradually. Mean if let's say if you know the boiling point of these two, this and this, by by taking the difference between two boiling point of two consecutive members, we can predict the boiling point of next member. Just adding the gap between the boiling points of methane and ethane, and when the difference will be taken between the boiling points of these two members, the same, just as boiling point increases, just uh, increase the little bit the gap. If the gap is here, like say 8, you can see here the gap will be 10. It depends. At least 4 to 5 members, or the difference between boiling points of 4 to 5 members will be given to you so that you can easily predict the boiling point of the next. When it is said predict, that does not mean you have to write the exact boiling point of that. There can be a difference of 1, 2, 3, 4, 5 below that number or of that number. Okay. Then they have similar chemical properties. In their type of reactions will be similar. For example, all the alkanes, they undergo combustion reaction, they produce CO2, H2O. We will study this one, chemical properties of alkanes. All the alkenes can be prepared by addition reactions because they're unsaturated. When double bond is broken, electrons are available. We can add anything over there. You understand? That is all for today. Inshallah, we will be starting from here for the next lesson. All the organic chemistry will be inshallah delivered here, topic by topic wise, along with past papers, and you have some knowledge of it. Today, I'm not, not solving any paper because any question, because the knowledge is limited for alkenes only. The question comes by mixing different topics. You understand?